The Coda, Beauty and the Beats. The dictionary defines a coda as 1. A concluding musical section distinct from the main structure, and 2. Something that rounds out or concludes and is interesting in its own. My coda introduces a few other topics in music that are intimately connected with mathematics and ends with a cadence to the course. First, the golden ratio. The famous golden ratio of visual art and architecture and nature has a musical equivalent. Composers could use the idea to divide the number of bars or measures in a piece into 2 parts, whose ratio is the golden one. The climax of a piece could then happen at the so-called phi number. Various researchers claim that there are examples in works of Bartók, Debussy, Stravinsky, and yes, even in Handel and Beethoven, but it is highly questionable whether any of them had the golden ratio in mind as they were composing. Modern composition. The music of Arnold Schoenberg is based on a 12-tone system called a tone row. He completely abandoned the tonal center, the home key or bass note. His intriguing 5 pieces for piano opus 23 has in every group of 12 notes, each half note appearing exactly once. Modern-day composers are even more innovative and push the frontiers of notes, scales, and rhythms. Aleatory music relies on probability and randomness to compose. John Cage is a prime proponent. Computers are now being used to compose music. Programmers have developed algorithms that can, for example, produce decent approximations to Mozart. They're not Mozart, but they do suggest his style. And that's AI, and it will only get more sophisticated. Is your melody a new one? The Parsons code uses simple notation to identify a piece of music by the up and down changes in pitch. At the website Musopedia, the open music encyclopedia, one can input a Parsons code to search for any piece of music. Going digital, or using digits other than your fingers. Mathematics has changed the delivery of music in our digital world. Here are 3 ways it has done so. Number 1, math has changed the notes we hear. Auto-tune, first made famous on an album by Cher, was the first piece of technology that could correct an out-of-tune note. Digital methods separate the spectrum of waveform frequencies, replace those that don't match the expected correct ones, and then return a fixed-up waveform. A combination of advanced math and fast computers makes it possible to do this in real time. Math turns bad notes from a singer's mouth into good notes from an audio speaker. Number 2, math has revolutionized how we carry around music or stream it wirelessly. At the highest fidelity, a CD would hold less than 2 minutes of music. Beethoven's Ninth would need 35 CDs at that rate. Audio compression reduces how much information is stored without a noticeable effect on the listening experience. Sampling, where only some of the points on a waveform are used, is a combination of advanced math plus psychology, electrical engineering, and computer science. In essence, it keeps the parts people will hear and drops the parts they won't notice. That reduces the storage and streaming demands. In short, mathematics has made possible file formats such as MP3s and streaming services such as Spotify that were unimaginable a generation ago. And number 3, math makes music on a CD sound cleaner than music on vinyl records or cassette tapes. By encoding the music digitally into zeros and ones, the strings of digits can be checked and errors corrected. It is analogous to the check digits used to verify credit cards or other security numbers. A CD has about 20 billion bits, zeros or ones, of which about 50,000 could be incorrect. Using the mathematics of codes and cryptography, all get corrected. That's why you can write on a CD with a Sharpie or scratch a CD. On vinyl, you'd hear a skip. On a CD, you wouldn't. Math and music, the same, but different. Mathematician David Kung, to whom I am grateful for many of the ideas presented in this course, has pointed out the differences and the similarities between mathematics and music. Let's start with the differences he enumerates. Math can't tell a composer how to orchestrate a piece or how to decide which instruments should play which parts. Math can't tell a pianist how hard or softly to hit keys or how to vary the tempo with rubato, ritardando, and accelerando. Math can't yet compose a piece with a theme and coherence. It can only predict the next logical notes. Everyone enjoys some form of music, even if they don't understand it or can't play it. It is universally accessible. Math, not so much. And now, the similarities he identified. Both require pattern recognition. We recognize number patterns like 2, 4, 6, 8, and can predict what comes next. We expect musical passages to end with a cadence. We expect a dominant seventh chord to resolve to the tonic, to sound complete. Both fields require considerable practice to master. And child prodigies typically happen in only 3 fields: music, math, and chess. Now, here are my 5 similarities between mathematics and music, beginning with my ABC. Abstractness. Neither needs a reference to the natural world, even though sometimes they have one. Beauty. Music obviously has an aesthetic aspect. Less obvious is that mathematics does too. Mathematical ideas, like musical ones, must fit together in a harmonious way. As mathematician G.H. Hardy put it, beauty is the first test. There is no permanent place in the world for ugly mathematics. Creativity. Both are endlessly creative. New music, new mathematical ideas, new proofs, all are acts of creation. Infinity. We will never run out of math or music. Math gave us definitions of infinity and, in fact, discovered different levels of infinity. We can use math to show infinity in music. David Kung notes that with just 12 notes and 3 note lengths, 36 to the 10th power different 10-note melodies are possible. It would take 1 million songwriters, each writing 1,000 melodies a day for more than 10,000 years, to write out all of these melodies. And satisfaction. Mastering or simply appreciating math and music provides great satisfaction and solace when needed. Symphonies, sonatas, and theorems can be therapeutic. The first letters of my 5 similarities are A, B, C, I, and S. Rearrange them and you spell basic. Math and music are basic elements of society. The B can also stand for brain. Studies of infant cognition have demonstrated that almost from birth, infants start to think mathematically and musically. Perhaps the brain is wired to process, remember, and understand both math and music. The intimate connection between mathematics and music is based on the similar patterns of thought that underlie both. An appreciation for the math behind the music enhances the knowledge and understanding of one of the most important and enduring art forms in the history of humanity.